Hello, my friend. Welcome to my course on the C programming language. Yeah, another course online on YouTube. Why? There is plenty of courses online. Why the heck we need another course? Well, I think that all the courses that you can find online on YouTube especially are not really tailored to real beginners. For real beginners, I talk to the people who see computers and don't understand absolutely nothing. They can only go on Google and search for porn videos and Facebook. That's the target. That was me initially, so we'll do, guys. Come on. So I decided to create this course to bring you from 0 to 1, sort of. I want you to understand some very important ideas of computer science, and we're gonna do that thanks to the C programming language, which is, in my opinion, the best language to learn how a computer works and to learn how to speak to this fantastic machine. I'm gonna follow the C programming language book that now I'm gonna show you. The C programming language by Carnegie and Ricci, which is the gospel of the C programming language, because, well, they are the creators of the language, so who better than them? Here it comes. Here is the book, the C programming language by Carnegie and Ricci. And yeah, I'm gonna follow step by step this book, which is kind of complicated if you don't have a background in computer science in general. For me, it was a really tough read, and there was not very good material online. So that's my turn. That's my turn to give back to the internet something. By now, I can write pretty good code on this language, so I want to give my part back to this fantastic internet self-taught coding learners. So this is the book. You're smart enough to find your source, and yeah, we're ready to start. With this first series of videos, I want to cover the fundamentals that are not highly tied to the C language itself, but they are more general. They are some ideas, some principles that must be known in order to be a good programmer. These are the basic, the fundamentals, indeed. On top, you will build all your programming skills, all your knowledge. Let's start from the Pareto distribution. What is this? The Pareto principle states that 80% of the outputs come from 20% of the inputs. What does it mean? Well, this is an empirical observation that this fellow Pareto made about the nature of stuff, the nature of things, sort of. He saw that in many contexts, we have always that the 80% of the results come from the 20% of the efforts. For example, in a startup, you have 20% of the engineers that are doing the 80% of the works, or that 20% of the people have 80% of the money in society. This is kind of an empirical observation. This is, of course, not always true, but I would say that this is an interesting idea coming from the fellow Pareto. How does it apply to our purpose of learning a language? Well, if you want to learn a language, and I'm talking in general, not a programming language itself, but even natural languages, for example, English, French, Russian, and so forth, you'd better start by memorizing the most used words. For example, you can memorize the 350 words most used in a language, and you basically can already speak the 80% of the language. For example, in Pareto terms, you learn the 20% of the words and you can speak the 80% of the language. For example, go to search zip low English words. The zip, I'm Italian, I cannot speak properly these zip slow English words. Okay, this is gonna tell you exactly the top 100 words used in the English language. As you can see, of course, we have at the first place the is the most used. You'd better memorize as a first word this one if you want to learn English, right? Because this is the most used. Probably in every sentence you get this word in the English language. So you get the idea, right? If we want to learn well the C programming language, we'd better start with the most useful keywords, patterns, ideas. That's what we're gonna do with these first videos of my series. We're gonna learn the 20% of the C programming language that is gonna entail the 80% of all the programs. The stuff that you will always stumble upon in your programs. Okay, let's go on. We're gonna start from variables. What are variables, what they are used for, and so forth. Then we have arithmetic. Arithmetic is simply the manipulation of numbers, you know very well. Functions. What are functions? This is a really, really important topic in programming. Functions are really crucial. What do we mean by input and output, and what is the control flow? These, I would say, are the core idea of coding, not only of the C programming language. This stuff you will find in every language, because this is the way we humans speak with a computer. These are ideas encompassing all the language: C, Python, C++, C#, JavaScript, Ruby, Fortran, and God knows what. So we're gonna start from the variables. To understand really well what is a variable, we have to understand what is a computer. Okay, so this seems like a mouthful. This seems like impossible to understand, but with the power of abstraction, which is a really important word in computer science, we're gonna understand how to exploit a computer without knowing every little bit of it, okay? I'm proposing you now a parallel to understand what is a computer, and the parallel is with the human body. How can we describe a human body without losing sight of what is going on? Let's try to describe a body starting from the atoms. So I'm gonna tell you, okay, a body is composed by carbon, hydrogen, nitrogen, oxygen, and yeah, these are the main 4 atoms of a body. Then we have some selenium, magnesium, and other atoms. Okay, these ones are linked all together in a specific pattern, and okay, you understand, this is impossible. If you want to describe a human body starting from atoms, you're lost, my friend. Okay, you need to raise the level of what? Level of abstraction. You have to go a little higher to describe what is a body and to understand what is going on. You can raise to the level of cells. For example, you can say, okay, a body is composed of many different kind of cells. For example, you have neurons, you have myocytes, you have enterocytes, and blah, 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 blah. Still too difficult, okay? The level of cells is still too low. I would argue that a good level to describe what is a human body, if you have to describe to an alien, you can say, well, a human body is a collection of system, I would say. We have, for example, a system to process reality. We have a brain and we have a spinal cord. This is the nervous system. It is composed of these neurons that are controlling all the muscles. And inside this stuff is consciousness being processed, and apparently intelligence is there. So we have a system that is where the intelligence is, where the consciousness is, and so forth. Then we have another system that is processing energy, the digestive system. We have this amazing system is able to take food and transform into energy. This energy goes to the brain, to the nervous system that is processing consciousness, and so forth. You have muscles, which are the way by which this body is able to move around. So you see, I divide a body into conceptual chunks, into conceptual systems. This system cooperate one each other to give rise to a human body. Okay, this is a good abstraction. This is a good model to describe what is a human body, understanding what is going on. I can give to an alien a good description. Would you agree? We can do the same with the computer. We can start from the lowest level of reality, which is a series of electrons moving around. If we want to start from there, we are super lost. Not only lost, but super lost. And I need to raise a little bit. We can go a little higher. We raise to the level of logic gates. Logic gates, let's see, logic gates are these tiny chips, as you can see from the image here, logic gate symbols. We have different kind of logic gates. By the way, you can build an entire computer, full-fledged computer, only with the NAND chip. And I take the occasion to show you a marvelous course that I took, which is called NAND to Tetris. You see, from NAND to Tetris. I highly suggest to you to take this course. It's free, and it is gonna allow you to create a computer from scratch. So the idea is that you start from this logic gate here, you see, this NAND, and then you're gonna create a full-fledged computer in which you're gonna play Tetris. This is madness. So this is by far, I would say, the best course I took on computer science, because if you want to understand really what is going on with your computers, you have to build one. That's the only way. Otherwise, it's too complicated. Okay, let's close this parenthesis. So these are the logic gates that creates your computer. This is still a too low level of abstraction. You're too low. You need as well as a human body, to raise the level. We can raise to the level of systems that cooperate one each other. In computer, we can very abstractly, very superficially perceive two main systems. We have a calculator and we have a place where we stock data. So we have an arithmetic logic calculator. What does it mean? Arithmetic, you know very well, is addition, subtraction, division, multiplication, modulo operation that you will know. And for logic, we mean the operations like, is this number major than this one? Is 10 major than 5? Yes or no? The result is going to be true or false. Yeah, our computer is able to process true and false result. This is the logic. So silly operations. For example, 10 is major than 5, 10 is equal to 5, 10 is minor than 5. This is the logic that the computer can perform. Cool. So we have this arithmetic and logic calculator. What is that? Well, it is the ALU. I'm sure you heard about that. The ALU is processing numbers. Where do these numbers come from? Well, they're coming from a place where they're stocked. Namely, well, this is the RAM, the memory of the computer. We have memories of 4 gigabytes, 8 gigabytes, 16 gigabytes in modern computers. This is the place where the numbers processed by the ALU are stocked. Okay, so I can perceive my computer composed of an arithmetic logic calculator and a place where these numbers are stocked. That's my computer in my mind as a programmer. This is a good mental model to perceive this madness of a computer because it's a very complex and complicated beast. Pay attention to the word complex. The opposite is independent. So complex means that has many parts which are interrelated, and that's exactly a computer. It's very complex. It has many parts that are communicating one each other, and of course it's complicated because it's complex. Okay, you ready to go on? Now let's check very briefly what is a real RAM chip. Well, this is a RAM. This is the real deal. This is the chip. As you can see, as programmers, we don't understand nothing what is going on if you watch this image. This is, by the way, stuff that is taken care of the electrical engineers. This is not for programmers. Nonetheless, it is good to understand how these chips are made. That's why I prompt you to do the non-trajectories course in which you're gonna build your little RAM. Okay, this image don't tell me anything. I need to create a model, a mental model, like the one we did before with the two system computer. So I abstract my RAM in this fashion. At the end of the day, a RAM is just a series of little bulbs that can be turned on and off. We have inside a RAM many lines. These lines are composed of 8 bulbs. You may have guessed a line is a byte. So a byte is a line inside my RAM that is composed of 8 bulbs that can be turned on and off. Of course, we don't have bulbs, we have transistors, but the idea is exactly the same. Every line inside my RAM has a specific address, as you can see from the image. This address has a very strange number that is composed by numbers and letters. You will find very soon what is this number about. I just tell you that this is an hexadecimal number. This won't make any sense to you by now, but it will. And basically, that's it. My RAM, for example, that has 8 gigabytes, is composed by roughly 8 billion lines of bytes. 8 billion lines composed by 8 bits each. 1 bit is 1 bulb that can be turned on and off. That's why it's called bit, because it's a binary digit. It means that it can be in a binary state, 1 or 0. That's it. I, as a programmer, see, okay, I have an arithmetic logic calculator, and I have roughly 4 billion bytes in which I can stock stuff. I can turn on and off bulbs, and this will mean something to me, allegedly, okay? Let's go on. As I told you before, a byte is one line composed of 8 bits, 8 bulbs. Why a byte? Why this name? Well, because a byte is a byte of information. Programmers always like to make fun. These jokes are pervasive in computer science, so it is normal. For reference, 4 bits are called a nibble. So you can understand where all these come from. So a byte, what is that? Well, is a chunk of information, a very little chunk of information in which I can stock something. I told you before, 4 gigabytes are 4 billion bytes. Every byte has its own address that is written with this hexadecimal number. Okay, you have a good framework of what is a computer, and maybe you start to understand how you can exploit it. Inside these bytes, you can stock stuff. What stuff? Well, this stuff is called a data type. In C, we have two family of data type. We have the data type int and the data type float. These are two families. Okay, so an integer, what is an integer? Well, an integer is a digit. For example, 1337 is a normal digit. A real digit is a 1 with a point. For example, 1337.42. This is a real number. This is a number that has a point. Okay, that's the difference between these two families. Cool. Given these two families, I can decide, hey, dear computer, I want to take 1 byte and has to be of the family integer. You see? What is this type? What is this data? Well, this data is a char. Inside the family integer, I have char, short, int, and long. Okay? But you will soon discover that when I say to the computer, hey, dear computer, I want a char, I'm telling, hey, I want 1 byte. When I want a short, I'm telling, hey, I want 2 bytes. When I want an int, I want 4 bytes. You see, I have an int, which is also a data type that I can decide inside my family. And then I have a long. For a long, I want 8 bytes. So maybe you don't understand what is going on by now, but you perceive that, okay, maybe a long has more space than a char. And maybe inside a long, I can stock more stuff than a char. Cool. This is a good intuition, my friend. And you see that a long has the same size as a double. So what is the difference between a long and a double? Well, there is a really important difference between a long and a double, not in the size of the data type, but in the way data is stocked inside these bytes. That's why we have a core difference between real data type and integer data type, because numbers are stocked in a qualitatively different fashion. Okay, you don't understand by now what is going on. Don't worry, you will very soon. Just keep in the back of your mind that we have two data types, integer, real, and inside these families, we can choose how many bytes we want. Cool. So I have my beautiful machine, my computer, which is a calculator and a place where I can stock my numbers. So at the end of the day, what is my RAM? Well, my RAM is just a notepad where I can write numbers. How can I write numbers there? Well, with my pen. My pen. What is my pen? Well, my keyboard, my friend. The keyboard is the magic tool that allows you to write numbers inside your RAM. Okay, so you can perceive you have a piece of paper and a calculator that can perform arithmetic logic operations. That's the framework you need to have. Let's start to do something. I want to write in my notepad, namely my RAM, the number 42. Here I wrote a piece of code which is int nab is equal to 42. You see this? This is a variable, my friend. This is a variable. And I'm saying to the computer, hey, dear computer, I want 4 bytes. You see here, int has 4 bytes and is of the family int. Int has the same name of the family data type, integer type, don't get confused. I say, okay, there, computer, give me an int. So the computer knows, okay, he wants 4 bytes and he wants the data stock in the int form. Call these 4 bytes nb. nb is the name of the variable and give the value 42 to this variable. What is going on here? The computer is giving me 4 bytes in memory, as you can see, and is gonna set the electrical state of these 4 bytes to the value 42. You see here the configuration of these bits. These bits have the value 42. By now you probably don't understand if you don't know binary, and that's normal. But the big idea that I want to give you is that when you write this piece of code, int nb equal 42, you're saying to the computer, give me 4 bytes, call these 4 bytes nb, and put the electrical state inside these 4 bytes to 42. This is the number 42. I need this number. I will use in my program. So please do that. Cool. And the computer is going to do that. It's going to search in the memory in those 4 gigabytes, not really all the 4 gigabytes, but just for the ease of comprehension. In my RAM, it's going to search for a specific place and it's going to set the electrical state to the value 42. That's what's going to happen. I want to show you the difference between a float. Look here. Here I have a float nb is equal to 42.00. This is a real number. This is a float indeed. The value nonetheless is the same. The value is 42. But you see that the binary configuration is totally different. For my 42, I have, starting from the top, 00101010, okay? And then all the rest is 0. These are non-significant zeros, are like the zeros in the decimal numbers. If you have 0042, the first two zeros are not significant. This is the same idea here. So you have 0, 1, 0, 0, 1, 0, 1, 0, 1, 0. This is 42. Here you have 2 bytes which are zeros, and then you have 0, 0, 1, 0, 1, 0, 0, 0, and then 0, 1, 0, 0, 0, 0, 1, 0. What a mouthful. Maybe you don't understand what is going on, but you perfectly see that the configuration is totally different. Same value, different configuration. That's because there is a qualitatively difference in the way our computer stocks data inside our memory, given that this is of the integer family or the real family, okay? That's a really core idea that you have to understand. The first bit in both cases is for the sign bit. So you see the blue binary digit is just to tell me, okay, this is positive or this is negative. So I made the sign bit blue just to see very well what is going on. In both cases, it's turned off because the number is positive, plus 42. So let's finally understand this idea. As you can see here, I have a char and a short. Char and short, as you know by now, are of the family integer type. Char and short. Cool. These two data types have only the sign bits, and the 7 bits for the char and the 15 bits for the short are for the value itself. For example, you see here, when I have my char, I have 1 bit for the sign, and then the rest of the bits are for the value itself. The value itself is 101010 in binary, namely the value 42. On the contrary, for the data type float, I have 1 bit, which is the sign bit, and then I have other 8 bits, which are for the exponent. So it doesn't need to make sense by now what is going on. Just you have to understand, okay, 2 data types, reals, integers. Integer have a particular pattern configuration when they are stocked, and floats, reals, have a specific pattern configuration. They have the sign bits and the exponent bits. So they have a qualitatively different way to be stocked. So the difference between reals and integers is the core idea I wanted to give you in this first lesson. Now we're going to understand practically what I'm talking about, and practice is always much better than theory, okay? So here it comes. We're gonna open our terminal. Don't worry, by now you don't have to understand nothing of what is going on. I want just to give you a taste of what is coding and what is programming in general. So this is a terminal. This is a place where you can have a dialogue with your computer. Now I'm gonna type some magic commands, and now let's see. I have my playground. Here it comes. This is a program that is doing something. Okay, this is a program that is printing the binary configuration of some data type. Of course, you should not understand nothing. This is gonna be like Arabic to you by now, but okay, no problem. We're gonna compile this code. Yep, the C code has to be compiled, namely translated into an executable. You will understand it later, this part, but now we just want to understand this concept of variables. So I'm gonna launch the program, and I'm gonna give as an input the value integer 42 and the float 42. You saw it before in my slide. Boom. Here it comes. This is the binary configuration for the number 42, which is this one, integer 42, and for the float 42. You see, you can appreciate that it is totally different. The value is the same, but the configuration is totally different. Now we're gonna make the value 1 integer form and 1.0 in the real form. Boom. You can see in the real form, totally different. Here is almost trivial to see the 1, even though it's in binary form. The difficult part, if you don't know binary, is what happens when we have a 2 here. You see, the 1 is changing here. This 1, 0 is 2 in binary. I will make a video, of course, where I explain the binary values. Cool. So you totally understand by now that when I have a value, for example, this one, and the same value in its float counterpart, we have 2 totally different binary configuration. To understand this point is important because it will pay its dividends when you're gonna do the exercise, because you know that for real numbers we have a special way of handling them. As I showed you before, we have 1 bit, which is the sign bit. Then we have 8 bits for the exponents, and then we have all the other bits for the value itself. Okay, so now we're gonna watch some negative values. For example, we stay for minus 42. What is going to happen in your opinion in our binary configuration? Well, we're gonna have something strange. The value is totally inverted, basically, and for the float, we don't understand nothing what happened. But for the integer form, we have, of course, the first bit is turned on because we have a negative number, and then we have plenty of ones here. Because the way computer stock negative numbers is with the choose complement method. Of course, I'm gonna explain in further videos. So I'm gonna change a little bit my program, and I'm gonna take this time a char. Do you remember a char? What is that? Well, a char is of the family integer, but it takes only 1 byte. So I'm gonna do the same, launch the program 42 and 42. This time, as you can see, the char, I have only 1 byte. I've taken only 1 byte. That's totally enough to stock this value. I have 10, 10, 10. That in binary is 42. Okay, this is the really first video. You understood that we have a notepad, the RAM, where I can write numbers. We have an arithmetic logic unit, a calculator that can perform some calculation. You will see in further videos on the numbers which are in my notepad. We stock these numbers in a binary form. There is a qualitatively difference between integer family and float family, even though the values are the same. Like in this case, 42 and 42. When I say char, short, int, long, float, or double, I'm saying, hey, I want 1 byte for char, 2 bytes for short, 4 bytes for int. Basically this slide here. So to make it extremely clear, let's make a program that I call variable. When I write, for example, int n is equal to 42, and then a semicolon, because this is a syntax rule of the C language. I'm saying, hey, dear computer, I want 4 bytes in memory. Call these 4 bytes n, and set the electrical state, the binary state of these 4 bytes into 42. Of course, int is a data type of the family integer, so it's gonna set the bits accordingly, okay? When I say float nb is equal to 42.0 semicolon, what I've done here, I've said, dear computer, give me 4 bytes. Call these 4 bytes nb and set the value to 42.0. This is a float, so you know that we have to settle the bits in a specific fashion with a sign bit and 8 bits for the exponent. Real numbers are not really used in real programs because they are not really correct all the time for reasons that you will. So we're gonna understand very well, first of all, the integer family. We have char that is used for characters in general, and of course we can give a value to all the chars. This is, by the way, the uppercase A, you will find out. Then we have short. This is a number that can be, for example, 32, int, and then long. Okay, long nb 3 is equal to another value. So you understood that you have this syntax. You say char, okay, I want 1 byte, give this byte this name, then assign to this byte the value 65, which is of course in binary form. You will find in the following lesson. All these data types are of the family integer, and yeah, I think this is an intro to our series. Don't worry if you don't understand everything like now, because the real knowledge is gonna come through the exercises, through practice. Just keep in the back of your mind what I've said, and everything will make sense. At a certain point, you will be like, oh, I know, damn. And yeah, that's it. Thank you for watching, my friend. Enjoy.